Hi guys, welcome to this new video part 2 on integration by parts. If you have not watched integration by parts special cases part 1, I will post it down the link in the comment section. So please watch it first and then you can definitely come to this video. So again, we are going to be covering three special cases as you can see on the screen. The first one is x ln x whole square dx, sec cube x dx, and sec x tan x dx. So these three are special cases which are to be solved using the integration by parts. So let's start with our first question. This is the easiest one in the series, which is x ln x whole square dx. Feel free to skip this part if you already know the question, and you can, definitely go to any of the question which you like or which you want to understand. So this is pretty straightforward case of integration by parts, right? So we're going to use the ILATE rule, and the ILATE rule suggests that the category of the function or the family of the functions should be in this particular order for you to take one function as fx and one function as g prime x, and whichever comes first is your fx. For example, I already talked about this in detail in the previous video. A is the algebraic part, which is over here, and L is the log part, which is over here. So obviously the log comes first, right? So since the log comes first, this is to be treated as f of x, and this is to be treated as g prime of x. Okay, all right. That makes sense. So as per the formula, we know that the formula for the integration by parts states that fx remains as it is. Then we write g of x minus integration of f prime x gx dx. This is the formula for the integration by parts. So all we got to do is just plug in our, sub in our functions. So fx is ln x whole square. So that's what I write over here. Gx is nothing but the antiderivative of x. And what is the antiderivative of x? That's x squared over 2. Minus, now let's be careful here. We have to differentiate ln x whole square. And what is the differentiation? We gotta use the power chain rule. That's where we have to be careful. So the 2 comes down. First, obviously, we differentiate this power. So the power comes down. 2, there's a natural log of x. As it is, and the power decreases by 1, so this is 1, and then we go inside and we differentiate ln x, which is 1 over x, and this is it. If you are still unsure about how I've done or used the chain rule, I have already made a video on the chain rule. I'll post it down as well in the comment section for you to easily see. You can watch that and ace your concepts on that rule as well. Okay, all right. This is what we have. And what was gx? We already have gx, right? We don't need to make any effort on that once again. And this is what we have. All right, so let's rewrite whatever we have over here as this. And I know that, just piece of decoration, this 2 and 2 is gone. X squared over x is just x. So I'm going to write x ln x. In fact, ln x, or natural log of x if you want to call it as this. And sorry, I missed one dx over here. X dx. So now it makes sense that why is this special? Because don't you think that we cannot really integrate this guy just like that? We again have to use another round of integration by parts over here. So another round of integration by parts when we use, once again, the fx is the fx is ln x and x is g prime x. This is what we have. All right, excellent. So we have everything. I think this is going to remain as it is, ln x whole square x square over 2 minus integration of, okay, so this is where I'm going to place a big bracket over here because I want to make sure that whatever is in, because remember that negative sign is eventually to be distributed in all these members, whichever comes here. And now again, I'm going to use the integration by parts. So fx remains as it is. Integration of x is once again x squared over 2 minus integration of f prime x, pretty straightforward. Ln x differentiation is 1 over x. Integration of g prime, so that's x squared over 2, and then dx as well over here. So I'm gonna place this over here. And I think I can continue my work over on the right side. I have enough space. So, okay, these guys are going to look as it is. So x square over 2 ln x whole square minus, and this is going to look like x square over 2 ln x minus 1 over 2 comes out, and in fact, you know what, it can be written as negative uh, integration of x dx over 2. Right, and we can easily integrate x, right, because we know that integration of x is x squared over 2. So all we have to do is rewrite our final answer as this x squared over 2, remember, and obviously there is a constant of integral c. So finally, if I just open the parentheses, distribute this negative sign, so our final answer is going to be x squared over 2 ln x whole square minus x squared over 2 ln x plus x squared over 4 plus c. So I hope you can see it completely. I'll just box it up, and this is our final answer for this question. I hope it makes sense. Let's move on to the second question. What's the second question? Sec cube x dx. Okay, so once again, this is a special case. And why is this special? Because integration by parts is usually a multiplication of two functions. That's one thing. And second is uh, they're of different families. But here, definitely it's not of different family. It's just sec cube x. Even if I try to manipulate this function, even if I try to write it as, let's say, sec square x times sec x, just for the sake of writing the function as a product of two functions, still I don't really meet the condition of having it's not a condition actually, but there's something which we have been seeing, that the two functions are not of different categories, and this is why this is special. And since they are not of different category, we can no longer apply the ILATE rule, right? Because the ILATE rule is applicable when the functions are of different category, and we can easily find fx and g prime x, but here we cannot do that. So we have to apply a little bit of intuition over here, that which should be fx and which should be g prime x. All right. Now we know that if we assume this as fx and this is g prime x, we definitely will have something called gx in our integration by parts formula, right? I can go back and you can see over here, this is where I have gx in the formula. It means that I have to find the antiderivative of g prime, right? Let's ask ourselves, is it easy to find the antiderivative of sec x or sec square x? Well, sec square x, because the antiderivative of sec square x is just tan x, right? And that is the reason why this is not going to be my fx and g prime x, rather it's just going to be vice versa. So let me just do away with this thing, and it's going to be a vice versa. So this is my g prime x, and this is going to be the fx. And all we have to do is apply the formula. So fx remains as it is. We have gx, which is tan x, minus integration of differentiation of fx as an f prime x, which is sec x tan x. Integration once again is tan x and dx. Okay, but we are not done yet. There are still some, tricks which we were to follow in this. So sec x tan x remains as it is. Tan x times tan x is tan square x dx. And once again, I don't really know how to integrate this tan x times sec x times tan square x. So I'm going to do some manipulation over here. Can I write tan square x as sec square x minus 1? Of course I can, because that's the Pythagorean identity from trigonometry, right? And now I'm gonna distribute, distribute, what do you call it? Yeah, distribute. So sec x times sec square x is sec cube x, and sec x times 1 is sec x along with a negative sign. All right, so far so good. We're gonna continue our work over here. And now we're going to distribute the terms. So this will be sec x tan x, and this integral can be broken down into two pieces. So that's going to look like minus integration of sec cube x dx plus integration of sec x dx. And does this look familiar? Well, this is our question. I mean, of course, excluding the negative sign. This is our question. And what can we do now? What manipulation can we do now about it? What I'm going to do is I'm going to assume that, and we have done this in our last video as well, I'm going to assume that the whole integral was I. And now in this step, I'm just going to replace, I think there is no integration over here. So this is sec x tan x only. And now I'm just going to replace sec cube x with I, and obviously integration of sec x is ln of sec x plus tan x and plus c we can add obviously later. So just add I both the sides and divide both sides with 2. So the final answer is I is equal to half of sec x tan x plus ln of sec x plus tan x plus c. So this is the final answer. I hope it makes sense. All right, the next question and the final question for this video is the integration of sec x tan x x dx. Why is this special? Because integration by parts, like we said, like we earlier read, it's usually of two different functions. But here I see three functions. Maybe two different kind, but three functions. So these two are of trig and one is of algebra, but they are three. So the confusion again arises, which one is fx and which one is g prime x? And that's where again our intuition comes in, that which function can be easily, differentiated and can be easily integrated. I would say this function can be easily differentiated because its differentiation is just 1. So if I take this as fx and I take this as g prime x, this complete unit as a g prime x, remember sec x tan x integration is easy because it's just sec x. So this is what I'm going to do, and I think you know what to proceed, how to proceed now. This was just the only trick for this question. So fx remains as it is, gx is sec x like I said, minus integration of derivative of x, which is f prime x, which is 1, integration of obviously g prime x, which is gx, which is sec x, and this is again integrated, and all we have to do is find the integration of sec x, which is ln of sec x plus tan x absolute value plus c, which is the final answer. I hope this video was helpful. Any questions, feel free to post it down in the comment section. See you guys in the next video. Bye bye.